Start streaming. Alright, get the beard all sorted out. Alright. Alright. So, welcome to the Sunday afternoon CircleCityCon Hardware Hacking Village stream, sponsored by CyberCityCircuits.com. If you need PCB assembly stuff, if you need a project built, you need 50 or 5,000 of a thing made, they are the people to talk to. They also have some nerdy kits and maker supplies and stuff like that, subscription box and all that fun stuff. But their primary business is in PCB assembly, so if you can get them some projects to build, that would be really good. Help my sponsors, that'll help me keep doing this sort of stuff. Alright, so where are we at? Oh yes, so this morning we took a look at through-hole soldering, and today we're going to work on oscilloscopes, multimeters, measuring things, and we're just going to try to figure some stuff out. So this is a interactive process, so if you have a question, please throw it in the CircleCityCon hardware hacking voice chat or the CircleCityCon hardware hacking regular text chat. I will have both of those open, and then I will from time to time be checking the YouTube comment section, chat section for questions there. And if there's anything you want to see, anything you want to ask about, anything you want to know more about, by all means, please let me know. We're going to, this is for you. I'm just going to entertain myself and kind of go over some basic stuff in the meantime. But if there's things that you want to know about, or if I have not explained something well enough, please, let me know. This is all for you guys. So, a couple of things we can mess around with today. We're going to take a look at. Let me switch to the right camera here. There we go. We're going to take a look at this. We've got 6 LEDs in a row. They're going back and forth. We've got an Arduino Uno right here. And it is a microcontroller. Very commonly used. We just had a wonderful presentation on how to use Tinkercad to simulate this sort of thing. So if you missed that, unfortunately, that one was not publicly streamed. Excuse me. Oh yes, I need to copy and paste the link to the YouTube. 1 second. Not yet. That is not what I want to. Copy, close. All right. Oh wait. There we go. And I should probably post that to the Twitters as well. One moment. Bear with me. Pretty please. Profile. Oh man, I got a bunch of messages I gotta go through. And tweet. Alright, let's switch back for YouTube so we can check for viewers and questions. Alrighty then. So, we should be able to do this now. Alright. Where were we? Alright, yes. We have the Arduino here. This is a microcontroller. We're using it to drive these 6 LEDs in a Larson scanner. We could be doing all sorts of interesting things. But this is what we happen to be doing today. We have all of the wires set up and all that. We're not really worried about the hardware. But we are going to take a look at the serial signal that is coming off of this Arduino. We're going to be using that transmit and pin 0 and 1 as was talked about in the last session. They're right here. Let's see if I can get this on camera. Let me see if I can get this on camera and in focus. I turned the autofocus off because it was messing with things, but that does mean I have to do it manually. Alright, so we have a bunch of pins down here. Here are the pins, the digital pins we're using to drive the LEDs, but down here we have the transmit and receive, which we leave empty, as was mentioned in the previous class, because they are serial pins. And we're specifically going to be looking at the transmit side of this, because that's where the signal is going to be. So we're going to, there we go, let's see if we can get this back in focus. There we go, back in focus. That's a little bit better, I think. Alright, so we're going to need to connect a signal to that transmit, and we're going to need to connect that signal to the device we're going to be checking things with. Let's take a look at it and talk about the interface on it. So this is an oscilloscope. This is a Rigel DS1054Z. It is a really good entry-level one. It's not too terribly expensive. It's pretty capable for the cost, and it's it's great if you're like me, not an electrical engineer, just poking around and trying to figure things out. We have some soft keys on this side. Every scope's going to be a little bit different. Every manufacturer's going to be a little different. But on this side, on this one, we can choose what sort of measurements we want to have down here. So you can measure peak-to-peak widths. You can measure peak-to-valley widths. You can measure PWM. You can measure frequencies. You can measure average voltage. And these buttons over here give you all sorts of options for that sort of thing. These buttons over here are going to change their context sensitive menu. So if we are looking at let's see here. Oh, there we go. Click this. We've got a context sensitive menu for that, or we can go back to channel 1 menu. What did I turn on up there? Oh, yes. Alright. Turn that back off. Here you can see we have our probe set at 10x, and there is a little slider on your probe that can be at 1x or 10x. That's the sensitivity of it. There's also a ground clip on it, so that needs to go to the ground. So, and then we have our little connector here that will connect to our signal wire. If we connect to the signal wire and don't have the ground, we get this weird signal here. We're not getting good data. So what we need to do is find a ground, and there happen to be a couple of free ground pins available. We'll grab one of them. We'll hook that up here. There we go. So now I have a ground hookup. And now when we hook this signal on there, we can see we are starting to see some data. Before we go too much further, we need to look at some of these other knobs. This knob here is going to change how much this chart on the voltage axis, which goes up and down, is shown. Right now we have 500 millivolts, and that is too small. So I want to switch that to 2 volts. So now, I don't know if you can tell via the video compression or not, but there's a grid here, and each grid block is 2 volts up. So if we look at this with 2, 4.5, that's about 5 volts, which is exactly what we expect off of a 5-volt Arduino. And then this axis here is time, and we're currently looking at 1 millisecond, and we can see a little bit of data changing here, but we're seeing a lot of static data, part of the serial protocol. We change that using this knob over here, so we can look out here, and then we can see several of those messages going by, or we can zoom in, and now we can see the individual up and downs of the logic signal. And if we wanted to, we could try to write all this out and translate it into hexadecimal or binary, or well, into binary and then into hexadecimal or decimal, or you know, ASCII characters. Fortunately for us, we have a tool on here we can use. So when we have this out here and we can see everything, we can go into the math menu and turn on one of our decoders. Now this is set to the RS-232, which is a serial protocol. It's set to channel 1. It's set to 9600 baud, which is the agreed upon speed that that a serial connection will be on. You may remember, if you're old like me, you may remember 24.4 or 28.8, I think it was 28.8 modems and the 56K modems. Those were the baud rates of those, and that is basically how long these dots and dashes are going to be for zeros and ones. Well, it's not really dots and dashes, it's ups and downs. And we have it preset for 9600 because I wrote the code on this, and I know that this serial connection is at 9600, and I don't want to tempt the demo gods much, so I set it all up to work correctly. That said, you know, when you're doing this in the field, if you're looking at a serial connection, you might have to spend some time messing with this, and also you're usually not going to get ASCII. Most microcontrollers are talking to each other in hex. They're sending hex strings back to each other on a proprietary protocol. Somebody's written in. It's really a headache to capture all those, characterize them, begin identifying the packet sizes, and then reverse engineering all the messages. I'm not saying it can't be done, I'm just saying it's a giant pain in the butt. The last knob we need to worry about is this one right here, which is turning this orange line on and going up and down. This is called the trigger. This trigger is set for, let's look at the menu on that. It's set for a falling signal, so as this signal falls past this orange line, we see there, so as it goes downwards past that, it's going to set the trigger, and that is going to define our capture. We can also change our capture by turning this knob and scroll left and right in it. But let's go back to our math menu, go back to our decoder, and let's turn that decoder on. And what do you know? We see some ASCII characters. We see an ASCII LED, a space character equals space character. Then we have a number that's fluctuating as it goes up between the LED 0 and 5. There's 6 of them, and it's 0 indexed. And then we have a character return and a line feed, which is basically a new line. So if we were to look at this in the Arduino serial monitor, which is what this was set up for, you would see LED 1, 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, over and over and over again as this code executes. If you're interested in seeing the code and seeing how this happens, it is on my GitHub. Search for Blendster Arduino example in the old Google, and you can find that sketch. I've been meaning to update it with some more comments, but it's very, very beginner friendly. It's designed with very little knowledge of programming or microcontrollers, and it's got a couple of I use an array for the pins to which I think is a good practice. It helps you abstract out because you might need to move the pins around for some other thing. Anyway, yeah, so that code is there if you want to see it, and this is how you can use a scope like this to find a known signal that you already know about. Nice and easy. But let's take a look at some other signals, unless there are any questions. I don't see any questions in the chat. I don't see any questions in the YouTube chat. Alright, so let's play around with something else. Alright, so that's reading a serial. Let's take a look instead at how these LEDs are used. So let's turn the math off. We're not going to be using math anymore. Let's go back to this. Let's change our time, because now we're dealing with much, much bigger signals. Alright, so now we have here and off, on, off. There we go. Still got this. And you can see that this orange line is right here because it's not catching this upwards. So if we want to change that, we would go back to this menu, change our slope up to going up. And now we're at that beginning, and we can scroll this over. So now we're too far. So now we're seeing this LED turn on and then stay off for a bit and then turn back on. And the reason for that is it's right here, right next to this one that's on the end. So if we switch to a different LED, let's pick one of the ones in the middle. We're going to see that there's a much bigger gap now because it's off. Let's see, there we go. Do we have a bad ground? There we go, that's stable. Wow. Let me try the other side. Are you happier there? You are not. Do I still have good ground? Alright. So let's add another probe to the mix. Where did I set my probes? Set them out of the way because they're on a, yeah, there we go. They're on a old aluminum heatsink that I pulled off of something to put on another project and ended up using a different one. And you don't want to stub your toe on that. So let's add a second probe to the system. So we're just going to add one here. I'm going to ground it to the same ground. And let's clip it on the other LED, and let's turn that channel on. So now what we're seeing is this LED turning on, this LED turning on, and then this LED turning on. And look at that, there's some overlap. And we can adjust the blue one up and down. So if we want to make it a little bit easier to see, we can pull it off that one. You can see that there's a difference there. These two, we've got the yellow, channel 1 and the blue channel 2. We're kind of pulling it artificially up. This has the advantage of being able to see the two signals even though they overlay each other a little bit, but it has the disadvantage that now these grid lines don't line up to the blue one as well. Although it's proportional, so you can still figure it out. So here we have this one, and there's a bit of overlay on both sides. And if you look at my code, you'll note that that is in fact true. We do have both LEDs on briefly, and the reason for that is it helps with the persistence of vision. It makes the animation smoother. If you try this code without that, the LEDs look a little too mechanical. But if you add this little bit of overlap, then it looks just a little smoother as it goes back and forth in this nice, lovely Larson scanner. Now on this one, if we want to reset 2 back to its default, there we go. We just click this as a button, and now they overlay each other, and you can see there's that overlap still. And one is at a slightly higher voltage than the other. Very slightly. So that is a way that we can probe to see how a circuit is working, whether or not it's behaving as expected. So if I wanted to see if that overlay was how I wanted it to be, and if I wanted to measure the amount of time, make sure that the code is doing exactly what I told it to do, because I told it a certain number of milliseconds. We can actually zoom in. There we go. Let's bring it this way a bit. Let me change this from that to any crossover. Alright, I see. So if we want that to be in the center, and now it's not triggering because we're not seeing it. Yeah. So let's change the mode to auto, see if that catches it better. It is not. So let's change the trigger from channel 1 to channel 2. That will be the solution to this problem. Not channel 3, channel 2. There we go. Exit that menu. Alright, so now oh, there we go. Trigger's in the wrong spot. Now we're making some progress. Alright, so now I think we can zoom in. There we go. It's okay if you barely know what you're doing. I barely know what I'm doing. So, now we can see right here we have a nice thing, and we can line this up on the grid. Each grid block should be 5 milliseconds. So 5, 10, 15, 20, 25, 30 milliseconds. And what do you know? It's exactly what I told it to do. So we could check that. So one of the things I do in my day job is software. I'm a software QA automation engineer for firmware on appliances. And we do things like measure the exact time a light is on. And there are specific measurements that we need to take from time to time to make sure that it responds quickly enough to a consumer input. So the consumer opens the door, we want to make sure that the light is on very quickly, so that there's not a gap that might be noticeable or and annoying to the consumer. So sometimes we need to take a look at a signal and see exactly how long between that signal and the thing coming up, and how long it was on, and what the pulse, if it was being driven to the right duty cycle, etc., etc., etc. So that's where using a tool like this in your day job can be very handy, even if you're not an electrical engineer. Alrighty. I'm going to check. I see no questions in the YouTube. Remember, this is entirely for you all. So if you have a question, throw a question either in the CircleCityCon Discord if you're a member there, or on YouTube if you like. I'll answer questions from anywhere. So to review, we've used the oscilloscope so far to find and decode a serial signal on this microcontroller, and now we've found the exact amount of time that these two LEDs are overlapping when they're on, and it is 30 milliseconds, which is exactly what I told it to be. It's I'm pretty impressed actually, because that is like, I don't know if you can see it on the stream or not, but it is right on, just bang on there. Like, it's not a little bit off at all. It's just nice and clean. 30 millisecond overlap. Wow. That's pretty cool. Not bad for a cheap little Arduino. So yeah, and then again, if we zoom out, now we're looking at 100 millisecond per. We zoom out even further. Let's look at 1 second. This is going to take quite some time to draw across the screen. There we go. And you can watch it just ba-doop, ba-doop, ba-doop. And we could add more of these probes. I've got 2 more probe spots, so we could add a couple of more LEDs, and we would see them in there as well. All turning on all at the same time, in their appropriate order. But let's take a look at another project. Because I have other cool stuff we can play with. Let's unplug the Arduino. And give me a moment. I'm going to put this over here. Grab this. I really should just grab a battery pack for this thing. I don't need to plug it into the... Don't have a USB... don't have one handy. Let's just unplug that. Plug that in. Alright, grab my keyboard back. We will switch to our fancy camera, and we'll take a look at what this is. This is an LED cube, and it is out of focus, but let's see here. Oh, that's getting worse. There we go. That's in focus. I need a producer. Quick, hit the focus ring for me. So this is a cool little kit that I built. Got it on Amazon for like $18, and did a live stream build of it. It took about 2 hours and 15 minutes or so to build. So if you want to watch that stream, see any of the tips and tricks that I have, what I learned doing it. It's pretty neat, but you may notice that we have LEDs that are changing colors, but they only have 2 legs. There's not a leg for each color, and there's not a leg for data or clock. There's just a power and a ground. So how's that work? Well, let's take a look. We'll switch back to here, and I'm going to turn the blue channel off for now. We don't need it, but we are going to use, let's see here, our yellow channel. We picked some LEDs that are not turning on very much. Let's go the other way around. Alright, now we're on an animation that's not very common. There we go. We should start seeing some stuff now. We have our there we go. Switch that to auto. And it's a little hard to catch. Let's reverse our connection. There we go. Let's change our and we're trying to find if we can get a good signal here. Well, it worked yesterday. I'm going to switch this. There we go. I think we're getting a better signal now. Let's change our that's the problem. We're still on the wrong channel. That will cause problems. So let's look at what we see here, and let's change this to $2. Still somewhat confusing. Alright, there's definitely more than power going through that. We can see all sorts of stuff overlaid in there. Unfortunately, the animation we're on is not hitting the LED that we're looking at, which is this one right here, super often. So let's see if we can't get an animation that I'm going to turn it off and back on. Now we're getting more action now. So now we can zoom in. Let's see if we see. That is very noisy. Whatever it is, very noisy. Let's get this. There you kind of see the reflection there. No questions on YouTube yet. Alright, so there we go. We're catching various chunks of this. Let's scroll back out so we can see this thing turning on and off, being driven different colors. So there's clearly some information being sent in there along with just power. When we have these clean ones, it's when it's white. When we have these dirtier ones, there's some sort of high frequency signal injected into the power that is telling it what color to be. There we go. We can see nice examples there. So that is really cool. We can see how we're getting both data and power. Alrighty, I'm gonna turn that off now. Let's see here. I have this thing we can take a look at. I'm going to hook up some power to it. And let's switch cameras so you can see what I'm doing. There we go, we're in focus. I'm going to hook up some power. And turn on my power supply. And now we can see we have a this is the cheap Chinese kit I've been using to do surface mount soldering demos, and I'll probably do one of those soon if there's no questions. If nobody has anything for me, I'll probably do some of that to amuse myself here in a bit. We are going to go over multimeters here in a bit as well. But here we have a 555 timer and a digital counter, and if we want we can probe that. So I can unplug this hook from here. Now we have a probe, and we can connect our ground to the ground. There we go. And now if we switch to our 200 milliseconds should be enough to see this, but there we go. Gotta move my trigger down. So here we can see the exact rate that this central LED that I have the probe connected is blinking at. It is blinking right along. And we can see it turning on and off. Look at that. Just regular as clockwork. And there it is on the scope. Just nice. Click, 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 click. That clock out is going to one of these pins. Is it this one? No, I don't think it's that one. There we go. There's that clock signal again. So, let's switch cameras. We've been able to find it, and it is right here on this. So now we have it over here and over here, and we can see it on the scope. Clicking right along. Here. If we look at these, we can see that these are much bigger signals. I'm going to zoom out so we can. There we go. Well, that's weird. Is that really doing that? Yeah. Look at that. We're getting two levels in there. Oh, that's right. We have a different reference voltage. That's what's causing that. And that we can explain later. It's how the circuit works. Basically, it's being powered directly through these transistors, unlike this thing. Well, let's see here. Let's go to auto. There we go. Come back down here, which is cranking right away. Look at that. And we can see we have a frequency of 3.62 Hertz, a period of 276 milliseconds, and a width of 138 milliseconds, and a duty cycle of 50%, which is exactly what those numbers would suggest. And you can see it right here, just on and off in equal amounts. That gives it a duty cycle of 50%. That's fun. Alrighty. Well, speaking of this particular kit, I have more of them. I have a couple more of them, and I have at least one more of them. Might be my last one. I might have to go on Alibaba and spend another $20 on cheap kits. So I'll put this away. Alrighty. Well, I'll go ahead and switch cameras. We're gonna we're going to get ready for surface mount soldering demo. So I'm going to turn off my... Oh no, we're going to do the multimeter first. Yeah, I am going to put the oscilloscope away though. Turn it off. Let's take a look at a multimeter. So we're going to turn the power off here. Put these back over here. That out of the way. Let's switch to our view, which should be able to see this. Oh, look at that. Alright, and is it in focus? Almost. It's almost in focus. Oh, let's... Alright, I think that'll work. Alright, I'm going to double check for questions. I don't see any questions. Remember, this is for you all, so by all means, if you have a question, let me know, and we will jump right in there. So this is a multimeter. There are many different types of multimeters. There are types that are designed for automotive use or industrial power use or medical or I mean, like everything. Like, there are multimeters for all sorts of things. You can diagnose a variety of things with multimeters. They tend to have probes. Here are the probes that came with this one. These probes have shields on them so that you don't accidentally short them against things while you're measuring things or short them to each other. These are really fancy probes. They, oops, wrong side. They also have the ability to have little adapters screwed onto these threads so that they can plug into this type of a connector. These can be unplugged and plugged into different holes for different purposes. Different multimeters will have different holes with different purposes. This particular one has this hole, this connection for, which is labeled here. Well, let's pull these out of the way so you can see. We have volts, ohms, continuity, diodes, capacitors, and temperatures. Then this is our common or ground, and then these are for milliamps to amps, and this is for 500 milliamps or lower. So if you want to measure current, you would use one of these. Tiny amounts of current over here, larger amounts of current over here. This particular multimeter, I'm told, or I've read in the instruction manual, that you can measure both voltage and current at the same time with it, which is really cool. But I have not yet set anything up to try that. So let's plug in our leads. It has a dial with a variety of settings. Each multimeter is going to be different. In fact, here's my old school Radio Shack piece of crap that I had for I don't know how long, 30 years probably. 20 something, yeah, 25, 30 years. Good grief. Yeah, I've had this probably 25 years. This one has this whole section here for measuring resistance from 20 mega ohms all the way down to continuity and diode testing. Continuity testing has a very low amount of current on this on this multimeter, and diode testing has more current. That's how much battery power it's going to use to try to test the circuit with. So if you're just checking for continuity, it's very little. But if you need to check a diode, diodes have forward voltages, so you need to put a little more voltage in there so you can see what happens. Over here we have the capacitor tester, which is in farads. Up here we have volts and a switch for DC or AC. Over here we have frequency in hertz, low and high. Then over here we have our amp meter, and again we have our amp meter here and our regular stuff over here. And then we have a transistor checker, which is right over here, emitter, base, gate, emitter. You can plug in different types of transistors in here and see if it's an NPN or PNP. And that's actually a feature that this multimeter does not have. But that's okay. That's why I have this thing. This thing does all that for me. So you can stick an electrical component in there, close the legs, press the button. Alright, there we go. It's a diode, and it's going to show us which direction the diode is and the forward voltage on it. Voila. The forward voltage is 1.89 value, 1.89 volts, and it's got a capacitance of 21 picofarads. Itty bitty capacitance. When you first learn about electronics, they tell you a resistor is this, a capacitor is that, and an inductor is that. But when you start delving into the reality of electronics, resistors have a little, resistors, capacitors, inductors, they all share a little bit of everything. So this diode has the tiniest amount of capacitance, but you wouldn't want to use it as a capacitor. But if you're doing high frequency enough work, then yeah, you might have an issue with that. Alright, I need to move it this way so we can see the screen. Alright, so this one we have our amp meter here, we have our small amp meter here, we have small voltmeter here, millivolt, milliamps, millivolt amps. Yeah, I think this is the ability to test both. This is the really interesting one, the one I use the most. We can measure resistance, but we can also do continuity, capacitance, and diode testing. Here we have frequency. Here we have millivolts and temperature. Here we have volts, AC and DC. Here we have a low Z mode, which is designed for working with things like the Arduino here. If you're messing with if you're probing a microcontroller circuit with your multimeter is going to introduce its own load in the system, and if you're measuring like an ADC or something, and you need it to be an accurate reading but not to mess up the microcontroller, that is apparently what low Z is for. I have not yet fully figured it out, so if I got that wrong, if there's an electrical engineer somewhere screaming, I apologize. Still no questions. Alright. I'm just going to keep rambling until someone asks a question. So the way to use this particular multimeter is you switch to the setting you're going to use, and it turns on. It's got a lovely backlight, which I'm a fan of. It also has a Bluetooth connection. It will connect to my phone, which I am a fan of. And it also has an SD card, and so you can record data to it, which I am a fan of, and like a lot of those features are missing on the cheaper multimeter. This one was $300. Comes from EV Blog, which is a gentleman who does a lot of electronics content on YouTube, and it hosts a podcast with my friend Chris Gamble, who is Contextual Electronics on Twitter. Highly recommend checking him out, especially if you're interested in PCB layout and design. He teaches a bunch of KiCad tutorials in the various versions. Every time they release a new version, he has to make another project in KiCad and put it on YouTube, which is quite a bit of work. So big props to him for doing all that. But let's explore this diode, shall we? We'll put it right here. We've got it in diode mode. This particular multimeter, you can see, has these red indications for different modes. But we have a LCD display right here. It's got the diode symbol displayed. You don't know if you can see that in the video or not, but we can put this on here and look at that. We see 1.785 for the forward voltage, and it lights up. And if we turn it around, we get nothing because diodes don't go the wrong way. So we can make sure that our diode is the correct way. Look at that. Now this also has a range, so we can switch it up to 15 volts. I do not recommend doing this on the regular, but you know, we're having fun. Look at that. Now that LED is nice and bright, but it's also experiencing significantly more voltage than it's designed for. So let's turn that back to 3 volts. So if the legs were cut on this and you weren't sure which one was the long and the short one, and you needed to figure out what the orientation was, this would be a good way of doing that. The thing I use this the most for is continuity mode, where when you touch the two probes together, you get a connection. So let's take a look here. So for example, if I weren't, don't set that on the LED, if I were not sure that this was a good ground connection, for example, where'd that other wire go? There we go. I could check. So let's say I know that I have a ground over here, and so I can connect here, and I don't know if this brown one is connected to to ground. I could then check and be like, oh, look at that, we got continuity there. So that yellow wire is connected through here all the way over to here, over to here. We have nice continuity there. And I use this all the time at work or in troubleshooting. Sometimes you want to make sure that a switch is plugged in correctly or whatever. You can use this to make sure that you've got continuity all along the wire. Maybe there's a break somewhere in the wire. Maybe and that can be hard to see. Maybe there's a loose connection somewhere. You need to go look for it. This is a good way to do a quick check to see, are they connected? Oh yeah, that's connected. We got a good signal there. Don't need to worry about it. If we have a bad signal through something, like for example this diode, which we should still get something. We get a little bit of light on the diode. I was hoping it would show me the resistance. It's not. Alright, let's switch it to resistance though. This should tell us. Alright, well let's do an actual resistor. Doing this upside down and backwards, so. Alright, so here we can see we have a is that a 2 or a 5? No, yeah, 5.5 ohm resistor. Of course, we can also, and this is another thing, I got this on Amazon, saw somebody else playing with it and was like, what? I want one of those. So I bought it and it's been fun. We can put this in here, press the button. It's just another type of multimeter. Unknown. Oh. Get it in the correct spots. And this one comes in at 4.95 ohms. Ah, who's correct? 4.95. And you are saying 5.6. 5.7 now. I trust the more expensive meter, personally. Yeah, so this is technically a multimeter. It's a component tester. It's testing multiple, it's metering multiple things. This is a more traditional multimeter. We can use it for other things, so if I want to see the health of the AC in my house, I can remove the two probes, and you want to be very careful doing this at home. Don't do it if you don't know what you're not, if you're not sure what you're doing, don't do it. Let's see here. What can I unplug? Alright. So you can see we are bang on 60 hertz, which is what we expect for AC. I'm going to disconnect part of that. I'm going to switch over to volts. And I'm going to change to AC mode, and then I'm going to plug it back in. And look at that. 123.48 volts. Which is also what we expect. I have used this to help diagnose why someone's kitchen appliances were blowing up in their house. Basically, I was able to show that both the frequency and the voltage were all over the place in her kitchen because there were issues with the power connection to the from the power company, and they the wind one of the three wires going into the house. If you look up at your house, you'll see three wires going in. One of those three wires was broken and just kind of flapping in the wind, and the wind would cause it to kind of spark. And that had a lot of very bad outcomes for the rest of the house. But it's, her kitchen appliances were the most sensitive. You know, your vacuum cleaner will run a little weird, but it's just a motor, so it doesn't care as much. But your microwave, on the other hand, has some delicate electronics in there that don't like rapidly swinging AC signals, so they ended up having to call the power company and having that fixed. Alright, so let's put that away for now, unless anyone has any more questions. This multimeter will do other fancy things. It'll measure the temperature. All sorts of cool stuff. Let's see here. Oh, I got two more. Okay. If there are no other questions, we'll do a look at this. Let me see if there are any questions on YouTube. I see no questions on YouTube. There's one potential question coming in on chat. Let's see what we got here. Alright, thank you very much. Got a nice compliment on our coverage of the multimeter. Let's do some surface mount soldering demos. Why not? So we're going to change the tip on the soldering iron around. Let me get this wire over here. Let's see here. Let's move this out of the way. Going to need to change this camera. You need to come back around. And this needs to go back into high mode. Yeah, you sit up there. Alright, now let's get the instructions out, and we'll talk about circuit diagrams and such. First, we need to see, what do we got here? Let's zoom in a little bit, not that much. Out a little bit more. There we go. We don't need that. So the instructions for this particular kit are in Chinese, and I don't read Chinese. I don't know Chinese. It's a lovely language, and might be fun to learn at some point, but this is just a mystery to me, right? I recognize things. We've got an NE555. That's a type of timer. We've got some other little bits of words in Arabic numerals that we can figure out, a little bit of English characters, but most of this is in Chinese. The beautiful thing is we don't need to speak Chinese or read Chinese to figure out what is happening here. What we have here is our bill of materials, also known as a BOM, and we can read it. Fortunately, it's also in American, or not American, it's in English characters, which is pretty common. We can see we've got UF, which is the English way of indicating capacitance. We've got LED labeled here. I don't know if that's Chinese for LED or not. It's probably the color, actually, because it's a little bit different between these two. And we have, these are red LEDs and these are blue LEDs. I don't know. Maybe this is LED and this is the color. No idea. Over here we do have some package sizes. So 0805, that's pretty common. LL34, SOT23. These are things that as you dip around in reading data sheets, you're going to learn more and more what these are through experience. So that's fun. There's a bunch of those we can mess with. We've got a bunch of designations here, D1 through D11, and we've got a number 11, so there's 11 of these. We've got 2 of these and 2 here. So this is our amount, of them that we need. Here are the values: a 2 mega ohm, 470 ohm resistors, 10K resistors. We've got some transistors. These are the SOT23s. That's a 3-pin package. We'll see those in a bit. And we've got a couple of packages. We've got our 555 timer, and we've got this CD4017. And if we look that up in Google, it's a digital counter, which I've already done. So if we now look here, we have a wiring diagram. You don't need to be an electrical engineer to figure all this out. I certainly am not one. But if we look at this, we can see we've got all of our pinouts for our 555 timer, and the passives that set the speed. So if we read the data sheet for that, we would see, what these values need to be in order to make it go a certain speed. When we looked at the oscilloscope earlier, we saw that LED blinking at the clock rate, that 50% duty cycle. That's this LED right here. This is the resistor that's the current limiting resistor here. And that's all tied to ground. We've got all that through here. We've got this clock also comes over to the clock input of this digital counter. This digital counter has a common output, which, or a clock output, I'm not sure what that CO stands for. I'd have to look at the data sheet again. But that goes out there and up and around, and we'll deal with that in a moment. And then it's got Y0 through Y9, so it's got 10 outputs. Those outputs are going through a current limiting resistor, through an LED, and then back to ground. So if we look at one of these right here, here's our 555 timer, here's that digital counter. The digital counter, getting that clock signal, goes through this LED and over to here. It's the same, they're all connected. We saw that clock signal was connected on the oscilloscope when we checked it both here and on, I think it was this pin here. And then we've got these LEDs, and we saw them, they light up in series. They just click, 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 click. As this thing counts up around its different outputs, it lights up a different LED. We also saw these 4 blue LEDs blinking super brightly. Now, the blue LEDs are hooked up a little differently. Let's take a look at that over here. So we've got that common output, or clock output, or whatever. It's going through these regular diodes. There's no little lines indicating that there's light emitting. These are just regular diodes. They're also colored in this data sheet fully black, whereas these are hollow. They've got an outline. These are protection diodes, and they are protecting current coming from this voltage in from going backwards into this. So it can only go this way. There's a 10K resistor here, and that is basically helping keep this transistor from floating. What happens is we get a signal that comes through this diode, through this resistor, and hits this transistor, and it allows current to pass from this side to that side. So it's in and then out. When it's allowed to do that, because otherwise it just goes this way. When it's allowed to go across, what we get is battery, current limiting resistor, blue LED, then transistor and ground. These are going straight from power to ground, whereas these LEDs over here on this side, they're going off these pins over here. So these pins over here are driving these, but these are being driven directly off of power. The same voltage, everything else, the same VDD or VCC that everything else is getting. The reason for that is these blue LEDs have a larger forward voltage, and they require more current. They require enough current that it would be potentially damaging for this IC that's driving these red ones. These red ones, it can drive all day, but the blue ones, they take a lot more oomph to get going, and they might cause damage over here. That's the short version of all that. So, let me see. Are there any questions about this wiring diagram? Circuit diagram. I'll give you all a couple seconds to get any questions you have about that before we go on further. Now, please remember, I'm not an electrical engineer. The main reason I'm familiar with this particular thing is I've, obviously looked into it quite a bit before I went on camera. It's not my first time seeing this. Alright, we got instructions. Now, another thing we want to do is change the tips on the iron. Let's switch to, well, let's put them up right next to each other, and you can see the difference. But let's switch to a super close-up view and see the real difference here. So this is the one that we were soldering with this morning, and it's great for through-hole. But this is much finer, and it's going to be much better for reaching in to these smaller components. So if we hold them both here, you can see it's just easier to get into these smaller spaces with the smaller tip than this big brute here. The larger tip will also carry more solder on it. It'll carry more tinning, and that is going to have a different surface tension, and that surface tension is going to give us different results. In this case, it would be very frustrating results. So what we want to do is we want to pull that one off, put our new one on. Now, if you were here for this morning's stream, or if you've watched this morning's stream, a lot of what we're going to do is going to be different. Let me turn the iron on. There we go. Click. I'm going to moisten my sponge. I don't use the wet sponge very often. I use the brass a lot more often. The reason for that is the wet sponge is going to pull energy out of the tip of the iron. We don't want to do that. If we can avoid that. Let's see here. Do we have any questions? Still no questions. Okay. Alright. We'll mess with that later. Alright. So we should be, yeah, we're up to temperature. So, soldering on a surface mount kit is going to be very different. We've got, let's see here. We've got, let's go back here. Let's look at the different solder. So, this is the solder we were using on the through-hole kits. And this is the solder we're about to be using. You notice it's much smaller, and again, if we throw the assembled kit in there, we can see why we want to use a much smaller solder. The big solder is just way too much. So let's switch to this view, and let's see if we can't zoom in a little bit more now that we're not doing documentation. There we go. Let's try to keep that roughly there. We've got a whole bunch of glare. Sorry about that. Now, because this solder is so much thinner, we don't have flux in there, so we're going to use a flux pen. This is going to clean the surfaces of the components the pads we're going to be soldering to and attaching components. We've got a bit of a fiberglass nose, which helps scrub. There we go. We got some parts, and we're going to be approaching this very differently. We're going to be cleaning this tip often. You see how dark and dingy it is. We need to make sure that it's nice and shiny like this. And we're going to keep very little tinning on this. We're going to do most of our tinning directly on the pads themselves. So we're going to get the, where's my tweezers? Gonna need our tweezers for this project. Now this is an IC, and it has a and orientation. Let's switch to our close-up, and let's see if we can't get our close-up to look where we're looking. There we go. That's nice. That's not too bad. So now we can switch between the two. Yeah, it's not too bad. Maybe a little bit better focus. There we go. Look at that. So there's a notch here on both of these. That tells us that the pin 1's on this side. And if we look on this package, we can see we have a little dot here. That tells us where pin 1 is. So pin 1 needs to go right over here on this side. If we solder it on backwards, it's certainly not going to work. So here what we're going to do is we're going to, we've put a little bit of solder down there. We're going to now touch the edge of that with the iron to heat it up. Set this in place, then remove the heat. Then we want to make sure it's in place by wiggling it, grabbing it by the part, wiggling it around. Not too strenuously, we don't want to bend that leg that's holding it. But we've got it in place. And now we're going to go across all the way over to here. The reason for that is this area is nice and warm, so if we just start going right here, right here, right here, as we might be tempted to do, we're not going to have good results, because we're probably going to heat this one back up while we're working on this one, and then this will melt, and then the whole thing will move. We don't want that to happen. Now, while I've been explaining, my tip is oxidized, so I need to wipe that clean. We need to keep the tip on this clean constantly, because it is a big problem. It's going to be a big headache if it oxidizes. We're going to have to touch both the part and the pad, which is a little bit harder to do. But you can see, if we're careful, we can get right in there and just add just a little bit of solder in there. And away we go. So we've got that whole side done. Beautiful. Let's switch to the slightly wider view, and you can see me do that again. We'll go down this side this time. It's really easy to get all of the solder on the leg and not on the pad, or vice versa. This is much harder to do correctly and takes a lot of hand-eye coordination and practice. I was not near as good at this when I started, I promise. I think maybe 1 in 3 of my projects worked without needing a little bit of rework. That is fixing. Alright, so we put this here. We've got our pin 1. One other thing we can look at, if we switch this to the up close view, we can see that on this side there's a bit of a chamfer, and on this side there's a square edge. This chamfer is another indicator that this is going to be the side with pin 1 on it. So we can get that ready right there. We're going to tack just a hair of solder there, and then I'm going to go left-handed on my tweezers, right-handed with my heat. Get that in place, just beautifully lined up like that. Then we go over to the opposite corner where we're less likely to accidentally reheat the original connection, and just come now. There we go. Look at that. All beautifully done now. Switch back out to the wider view. So that's not too hard. Alright, see if there's any questions. I'm not seeing any questions. If there's anything you all want to talk about hardware hacking, it does not have to be about surface mount soldering. I am just doing this because nobody has suggested anything else. Unfortunately, a friend of mine had to go to the hospital. That sucks. uh, Alright. Got a bunch of Twitter messages to catch up on real quick. Alright, let's get back to this. We're going to stream for probably another hour or so. Let's see, what should we do next? Let's do these round diodes. These are terrible. I will never put them on any kit, for, especially not for beginners. You know, maybe if I do a kit that's designed for difficulty. Look at these things. They're round. They do that. This is the problem with them. It should be pretty obvious. They just roll around. Miserable. But they're diodes. They don't have a long and a short leg. How do we figure out which direction they go? Well, let's look at them up close. There we go. We can see that we have a dark band on one side. That's probably an indicator of something. And if we look here, we can see that we have a thinner line here than we do here. So if I had to guess, we would say that the dark band goes over here. Now, we don't have to guess. We can use a multimeter, and we can put it on diode test settings, and we can put probes on each side, and then we could verify. And indeed, I've already done that in the past, and this is the correct orientation. But if you were doing this for yourself for the first time, I would highly recommend that you take a moment and double check. So we're going to put a little extra solder on there since it's such a large component, comparatively speaking. And we're going to put this in there. Now notice the surface tension on this is causing it to want to lift up. So in order to get it exactly in place, we're having to fight with it a little bit. That is unfortunately normal for dealing with surface mount components. Because the amounts of liquid are so small, the surface tension is going to be much higher, and we're going to end up with it wanting to cling to things and have, you know, we got to wrestle with it a little bit. So it can be less fun to do. That said, once you get used to it, you get the hang of it. I personally find it quite relaxing. And this is the sort of thing I do for fun. Can you believe I'm signal? Oh, I'm kidding. But there we go. We just put that in place, and notice well, let's switch to a more overhead view, because you can't really see there. And let's zoom in a little bit more. There we go. So there's not as much solder on this one, on the back, as there is on this one, because we've just kind of tacked it in place. So on this side, we're going to put a bunch on there, and then we're going to come back to here and add just a little extra, just to make sure that we've got a nice, good mechanical connection. Let that heat soak all the way through. Look at that. Beautiful. So let's do the other two real quick before we go on to something more interesting than these annoying rolling components. Notice how the surface tension pulled that part right on in. Once it had it, it just slurped it in. Then we can swing that around. Look at that. Beautiful. Come back over here. Well, the tip's oxidized and we're not conducting heat as efficiently. And since we're doing it in a much smaller area, it's going to be the soldering iron and the solder are going to be much more sensitive to that. Again, all part of the fun of surface mount soldering, and why I don't teach it at conferences the way I teach the through hole. It's just not quite the same. That said, I might consider doing a dedicated training at some point, but the conditions have to be a lot more controlled, and we have to have fewer students and a more set up a controlled environment, you know, the classroom and theoretically adults who are there to pay attention. There we go. One of the pains in this process is getting stuff out. So let's take a look at this diode. This is not like this one. I mean, it's really not like that one. There's a pretty big difference. This one has a long and a short leg. This one has no legs. No legs at all. We do, however, see a little green indicator, and if we turn it over, why, look at that. We have a green line with a little bar pointing in one direction. Now, does that bar point to the anode or the cathode? The negative or the positive? Good question. Usually, but not always, it points to the cathode, the negative. But we want to be sure. So I'm going to take the multimeter. I'm going to put it in diode mode. And we're going to test that theory by putting negative towards that notch. And look at that, it lights up. So if we turn it over, we can see we've got that green on that side. We're going to try that. And hey, it lights up. So, indeed, that is the correct way for that LED to go. Now, we don't have a plus and a minus on this diode indicator on the pad either. Instead, we have a narrow end and a fat end. And again, the fat end is going to be the cathode. And we know this because I've built several of these and they work. So we're going to get this ready for the component. We're going to put a little bit of solder in place. Get the left-handed tweezers. Slide it in place. Now that's not straight, and I don't know about you, but I want it to be a little cleaner than that. There we go. That looks a little more like I know what I'm doing. Hopefully. Oops. And of course I messed it up. There we go. One of the things that can happen is you can get both pads heated up and jostle it, you know, because this isn't fun enough. It's all part of the joy. Alrighty, let's see, are there any questions? Alright, we have a comment saying that they are enjoying watching, so thank you very much. We'll definitely keep going. Alright, let's do some more passives. These are the passives that control that 555 timer and regulate some of the outputs on there. So we've got R48, and we could refer to our data sheet, or we can be lazy and we can look at the last one we built. And what do we have in R48? We've got a 103 or 10K resistor, And then we've got our 470 resistor, and then we've got a 2 mega ohm. That's 2, 0, and then 5 more zeros. So 20 plus 5 more zeros is, for a total of 6 zeros, is 2 million ohms, or 2 mega ohms. So we know what we're looking for next. Let's pry them out of their little packages. Come on out. Alright, is this one okay, or did it get cut? It looks like it got cut a little bit. It might be alright. So we've got that. If we look in the up close view, I believe that's the yeah, so that's our 20. It's our 2 mega ohm right there. That's going to go in R49, as I recall. Yeah. Then we need, so that's not it. These are the capacitors. Is this a 10K? What do we got here? We got a 10K. Look at that. So I believe that was on the outside. And then we need a 470. Those are bigger 10Ks. Come on. Open up. There we go. There we go. Now, these do not have orientations that we would care about. Normally, we can absolutely solder them in upside down, that the text can be in whatever orientation. They'll work just fine. However, for the purposes of easily diagnosing any issues on your boards, especially while building prototypes, I find it convenient to line them up so that the text is all in the same direction, so that way you can hold this PCB in one direction and read as many of these as possible. So that is why I'm going to do that here. You don't have to do that on your end. You do you. I ain't gonna complain. Well, I'm not gonna see it. If I did see it, I might complain. But I'm not your boss. So let's get these in place. Now, these will like to stand up. They'll like the stovepipe, or tombstone as we call it. See if I can get it to do that on purpose. Yeah, see, just like that. Now it's like a little drawbridge. So we're going to hold that down with the tweezers, then remove the heat. And that's just down to that surface tension. These pipes are so small and light that surface tension of the liquid can pull them up. I will say, as you're doing this is one of those things where technique and being able to go quickly helps. Leaving the heat there too long, not great for what we're doing. So as you practice this, start on larger components than these. And get your, start on the through hole. Get really comfortable with that. Then do something this size. These 1206s, they're a bit bigger. They're easier to deal with. You get the hang of it. And then there you go. Alright, so now we have some capacitors. These capacitors are, we know that they're the right capacitors because they're the only capacitors of this size in the package. We have some smaller capacitors that came with it. Oh no, those are the resistors. There they are. So here are some smaller ones, but they are for the back. They're for practicing the 0603 size. And we're gonna brush the tip off of our iron. We need to keep this clean, super clean. Otherwise, we're gonna have problems. We're just gonna get these happy little capacitors in our happy little homes. There we go. Look at that. We'll go on this side. There we go. Look at that. Just lovely. And now we need 4 more resistors. And I believe those are also 10K. Or are they well, let's look at the let's consult the book of armaments. 470s go out there, 10Ks go right there, or 61. Yep, those are the 10Ks. That's what I thought. Yep, that's what I got right there. Alright. Aha. I do know what I'm doing. Sometimes. Occasionally. By accident. 4 of these. Out. There we go. Look at that. Cute little. Set them up here. Soon to go in their new homes. We don't have stripes on these. These are read a little bit differently. So if we zoom in, you can see we have it's generally separated the first 2 digits, and then the 3rd digit is the number of zeros. So we have a 10 plus 3 more zeros, so 10K. We already did the 20 plus 5 more zeros is 2 mega ohms. We've got the 47 plus 1 zero is 470. If it was if I actually said 470, it would be just 47. And then 103 again, 10 with 3 zeros. That's 10K. Because that's how it goes. All right. Let's pop these in place real quick. Won't take too long. And then I'm going to take a moment to check for questions. So if you've got a question or comment, throw it in either the CircleCityCon Discord Hardware Hacking Village chat or there on YouTube. I will check them both. Going a little bit slow to make them look all pretty. Alright, got them in there nice and pretty. Let's do the other side. Notice I'm using the edge of the iron, not the tip of the iron. And I'm touching both the pad and the part. Still very important. If you only heat up one of them, only one of them is going to get the solder. Alright, not seeing any new questions there. Not seeing any new questions there. Time for a drink of water. I suppose, now that we have all those done, we should probably do the LEDs going around the outside and their current limiting resistors. So let's get a few of those out. And few of those out. Get our tweezers. And a bunch of my resistors are upside down because why not? This is what they look like when they're upside down. This is what they look like when they're right side up. And again, they'll function just fine. Oh man, I do not like the delay on that. Oh well. Alright, so we've got a bunch of these. Let's flip this over. Get them ready. Now we need to use our flux pen and clean all these pads. This is going to clean any oxides and dirt off and leave it as pristine as possible, and within reason, so that the surface tension of the solder that we're adding doesn't have anything to fight with. So let's put our resistor in place. You see how the surface tension pulled it back in? And you can use it to your advantage. Now we need to put a diode in place. And we already know which direction we need it to go. Now these parts are really sensitive to heat. If you put too much heat on them, the plastic on the top of the lens will melt and separate, and then the diode is dead. It's dead, Jim. It's not coming back. So I'm just going to go ahead and get a few of these ready. Get you in place. Come on now. Get you in place. Get you in place. Come on now. Get in there. Get in there. There we go. Get you in place. Sit flat there, and then we'll come back and finish them all in. Just like that. Make sure they're all touched up. Beautiful. Is this? Yeah, this is what we're working on. Alright, that's going to be in focus. So I'll make sure you can see what I'm working on. I have in the past gone right off camera and just kept working, and that doesn't do you all any favors. Now does it? Get a diode in place there. A diode in place there. Resistor in place there. Resistor in place there. Now let's slide some things into place. I'm going to go solder in my left hand this time. Just the angle we're at. That's right, ambidextrous soldering. Just for you all. Because otherwise keeping it on camera is difficult. Oh, don't you bounce around on me. There we go. That tip's getting grungy. Gotta keep it clean or we're gonna have a bad time. There we go. Do the next set. Get them all ready. I need you to go there. I need you to go there. We need you to go there. Sometimes it sticks to the tweezers, which is why I have the toothpick on my desk. I'll just take it right off that way. And again with the left-handed soldering. Just get these in there, nice little homes. There you go. Stuck to the tweezers and lifted right out. Wait a second. Choose the correct orientation. There we go. Can you all see what I'm working on? Oh, that's the wrong way. There we go. Nope. There we go. Now you should be able to see what I'm doing. Alright, we're going to come back in there and just like that. Little bitty bits of solder. Any questions? Nope, not seeing any questions. We're just going to keep going. We're going to put on a couple more sets of resistors and LEDs. We got you right there. Got you right there, and you know what? We'll put you right out there. We'll just go ahead and do all 6 of these all at once. You go that way. You go that way. Alright. We have all those in ready to go into their new homes. More left-handed soldering. Oh, you would flip upside down on me. All part of the fun. For some definitions of the word fun. Come on now. I need you to be nice and straight and pretty. Can you be pretty for me? There we go. Alright, now we're switching back. And the last one, look at that. Got all those tacked into place. It's time to make their homes fully functional to the other side as well. Remember, we are creating both an electrical and a mechanical bond. We need to take care of the health of both. Alright. What do you say? Should we do a quick function test? See where we're at? Turn the power on here. Look at that. And so far they're all turning on. How's that? Boom. Now we just need to get the 4 blue ones going. Remember, this session is for y'all. So if there's anything you want to talk about, ask questions about, or see, feel free to chime up in the questions, either in the YouTube comments or up here on the Circle City Hardware Hacking Village chat, and let me know. Once I know what you're looking for, we will see if we can do that for you or not. Otherwise, I'm just kind of entertaining myself here, doing some surface mount soldering, and hopefully some folks are enjoying that. So we are going to be working on this corner and then this corner. Alright, so we can see that. Let's get our transistors out. We got 4 of those, and look at this, we got a chunk of one. That's not going to do anything. Throw that in the garbage. So we need to get one of these right there. We need our blue LEDs, which we have out here. Put that there, and then we are going to need a resistor. We'll put that there. That'll be ready for us. So now we're going to get everything ready. We're going to put a tack point there, there, and there. Then we're going to get in here with our tweezers. We're going to line this up. We do need to get this nice and careful. I have seen someone solder that in literally upside down and backwards. Pro tip, do not do that. If you gotta fight it to get it on the pad, you're probably looking at it wrong. We're gonna come in here. Oh, there we go. Presto, just like that. So let's get this one ready. And we'll do the same thing again. We'll get all our parts in place. You want to stick again? I have tweezers and a toothpick. Alright, now that we've got those in place, that down in place. Get you over there. These are the SOT 23 packages. I think it means it's 2 millimeters by 3 feet. But, you know, I'm guessing. I'd have to look it up. I'm sure Wikipedia has an article. we go. Look at that. Beautiful. Beautiful. All in place. Any questions? Still not seeing any questions. Alright, well, we've got 2 more of these to do. There we go. Did I did. Alright. So we're going to want to go there, and there, and there, and there, and there, and there. Now let's get our perts in place. This is the thing that takes me the longest in this whole process. I have soldered in a speed soldering contest once, and despite having to stop and talk for a little bit, happy to say I came in first in my heat. That was fun. Look forward to doing that in a more controlled environment at some point. Oh. The joys of working with tweezers. Things just pop out of them for no reason. You weren't actually holding that. Oh, yeah, upside down. That's what I wanted. There we go. Oh, that's not good. There we go, and look at that. Come back and finish these off. When the solder starts sticking to the iron like that, you can, oh, we're too oxidized. You can sometimes get it to flow off the iron in ways that it wouldn't in through-hole soldering, because the small amount of I'm going to see if I can straighten this up a little bit. I'm just not happy with it. There we go. Oh, that's a little prettier. Alright, let's check it out again, see if it works. Let's zoom out a little bit so we can see the whole thing. There we are. Oh, hey, gorgeous. Meow. Oh, did you have a nice nap, darling? Who's a pretty kitty? Yeah, you're a pretty kitty. Alright, power. We need to turn on the power. And then we need to put that on here. Look at that. All the LEDs are turning on. It works. It lives. Well, now it's time just to show off a little bit. So let's look at the other side here. We've got some stuff that is actually difficult to do. Look at these. These are a pain. I'm going to actually do them sideways. These are called resistor packs. when you have multiple resistors in the same package. They can be really handy for putting a bunch of resistors in a small space, which can be great when you are dealing with how expensive PCBs can be. You want to keep them as small as you can, but these are a pain to do by hand. So I recommend that if you're doing a project with them, you go through our sponsors, CircleCityCircuits.com. They have a PCB assembly house, and they have the sort of equipment that can pick and place these and put them in place and have everything perfect, all by machine, so you don't have to do all the very careful work that I'm doing to get them in place. Oh, come on. So those I was able to do with just a little bit of solder straight on the iron. Just a tiny amount. And no bridges. No bridges. Let's do another one, just to show off. There we are. Now I do have a true story about doing some of these once. We had them on one of our projects that we were building ourselves, the Hat and I. We were actually at CircleCityCon, and we wanted to make a couple more of these to give to folks. A couple of our friends who were there. And Skydog was there, so he was helping us. And Skydog and the Hat were understandably frustrated with these. They bridge super easy. You look at them the wrong way. So they were complaining, and I said, fine, I'll do them. And then I started showing off, doing them as quick as I could. I got another one. I got another one. And someone at the table may or may not have threatened to stab me with a knife if I didn't shut up. It was fun times. Obviously, it was playful banter. Alright, let's take a look at another really cool thing. So let's see. So these, let's see, where was that other resistor? There we are. So this is a through-hole resistor compared to a regular resistor. You can see that we've been working on here. These surface mount resistors are tiny, but they get even smaller. They get smaller than this as well. Look at that. Look at that. That is itty bitty. I think that's 0402. No, I think that's 0201. Well, maybe it's 0402. Anyway, we're going to put them over here on these little pads. If I can get it to quit sticking to the... Oh, you want some more pens, darling? Oh, who's a good girl? Meow. Oh, who's a good girl? Who's a pretty kitty? Oh, yeah, you are. Alrighty, let's see here. Alright, so we are No questions still? Alright, I'll do a couple of these. And then I may call it an evening. You're sticking to the tweezers again. Alright, let's get a little bit of solder on one of these pads. Look at that, just the tiniest amount. Let's get this itty bitty teeny little resistor in there. 0402. There we go. They make them even smaller than this. There's 0201s. I don't like doing them. I have done them. Here, I'll get it out. I'll show you. Yep, those are 0402s. And we can look right here. 0805, 0603, 0402, 0201, and 01005. Which you can't see. It's so small we can't even see there. And then there's another one. So if we take one of these 0402 resistors out, there we go, and we get our tweezers. You can see it's the same size. Look at that little thing. But they get even smaller. It's huge compared to this 0201. And it's a mountain compared to the 0105. And just in case you're curious, yeah, they all work. Alright, I'm going to put that back in here. I don't remember if that was in there or not. Oh well. Stick that back on the shelf. Alright, we were over here. And we were going to do another one of these. Look, there we are. Clean the tip. Just the tiniest amount of solder. Get that in place. And these will conduct heat super easily. And they will stick to the end of your iron super easily. So they can be an absolute nightmare to deal with. They slow me down tremendously. I don't want to do them very often in projects, but sometimes that's just the way it is. It's usually filtering capacitors. They gotta be close to the microcontroller, as close as possible, and you can practically put them on the pins if you make them small enough. There we go. There we go. So I'm just gonna kind of touch those up a little bit. Nice. Look at that. There they are. Itty bitty teeny weeny. Alright, it's past 4 o'clock. This is your last call for questions, comments. Let me know what you're thinking. I've been doing this for over 2 hours, and I think I'm going to take a break. I need to change into some work clothes and head up to my dad's house and my parents' place and help them fix the lawnmower while we still have some sunlight. And hopefully no rain. I gotta check the weather forecast again. Make sure there's nothing on the radar. Alright, well, with no new questions or anything, I'm going to let you all go. Y'all have a wonderful day. Thank you very much for being here. Remember, I love you. You matter. And to be